Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 713, subarray product less than k. So it is a medium level problem, and we'll first check out the problem statement and we will solve this problem using the two pointers approach. So we'll check out the problem statement first, then we'll look at the approach which we're going to use, and toward the end we'll see the code as well. Starting with the problem statement, it says given an array of integer nums and an integer k, return the number of contiguous subarrays where the product of all elements in the subarrays is strictly less than k. And in the examples you can see, like for example, we had 10, 5, 2, 6 and k was 100. They have figured out 8 subarrays such that their product was less than or strictly less than k. Okay, so we have to find all these subarrays from the given array. So there are multiple ways to approach this problem, but we will be using 2 points to do this, because if you go and see the constraint says nums of I, all nums of I will be greater than 0. Okay, so this ensures that if we keep on going towards the right, the number will keep on increasing for a fixed base. For example, 10 into 5 will for sure increase, then 50 into 2 will increase, and so on and so forth. So now this is what we know already. So now what we can do is we can fix one of our pointer, okay, and move other pointer until we reach the element which gives us which is greater than or equal to 100. Okay, because we want strictly less than k na. So we will move our right pointer until we reach any value which is greater than or equal to k. For example, in this case we will start with 10. Okay, it is smaller than k, so it will end up in being in our result in the set. Okay, now next is what? 5. So when we add 5, so basically we are adding two subarrays. That will be 5 in itself and 10 comma 5, right? 10 comma 5 and 5. So okay, 5 will be there and 10 comma 5 is also in the result, because the product of these two terms is less than k. Okay, now next we'll move again towards the right. We reached 2. Now here is the condition where the sum is 100. Okay, and we were looking for strictly less than k. So this doesn't satisfy our case. So now what we will do, we will just simply move our left pointer by 1. Okay, and now this is what we have. So next thing which we will have is what? 5 we already had. We have added 2, so we will have 2 and 5 comma 2, because the result was 10. Okay, and we'll just keep on doing this. We'll get all our answers for this. So this is the crux of what we will be doing. Okay, and if you see, using sliding window is very simple. We can also say sliding windows. Okay, now to calculate how many subarrays we'll have between any two indices, for example 10 to 5, 10 to 2. Okay, let's assume this. So there is a simple formula which can be used over here. So it will go something like this, that 0 1 2, or let's make it 1 2 3. We'll see. So we have 3 elements in it, 3 elements in our current consideration, right? So 3 minus 1 plus 1, so basically it will be what? 3. So these are the subarrays which this element will introduce. Like if added, these will be the subarrays which will be introduced if we add this particular element. Okay, and those will be what? Like 10 5 2 5 2 and 2 in itself. Similarly for 5 we have seen already, the array was 5. Okay, if we just had 5, then we had how many? 2 extra subarrays, right? Because 10, 5 and 5. Similarly for same, like 1 minus 1 plus 1, that's a single subarray because it is 10 only. So if you club all this, you'll get your answer, okay, of how many subarrays are possible till any particular point. So yeah, this is the crux of the whole solution. So let's check out the code. Okay, so first of all, I have handled the base condition where if k is less than or equal to 1, in that case we will just simply return 0 because it is not possible to have product of two sum if they are not 1 ending up being less than or equal to 1. So in that case we are returning 0. Next, I have defined the few variables which we will be using. Total count will be the result which will return at the end. Product is the current product, like product till our current right pointer, and left is the pointer which will keep a track of the fixed point. Okay. Now what I'm doing over here, I have started iterating the nums array, and we are using enumerate to get the index and the num in a single go. And what we will do with each iteration, we will update our product with num. Okay, so we will do that. Also, one more thing I forgot to mention in the explanation. Let's go to that first. Yeah. So like what we do in prefix sum. For example, let's say the prefix sum of the same array will be what? 10, 15, 17, and 17 plus 6 is 23. Okay, now let's say if we wanted to get the sum of these two values, what you would have done, you would have just simply subtracted for example 17, okay, minus 10. So 17 minus 17 minus 10 equals to 7, which will be the sum of these two integers. Okay, so over here what we are doing product, right? So it is something like 10, 50, 100 and so on and so forth. So in this case, instead of this subtraction, we will do division. So for example, at this point we reached 100, right? And now we want to remove this from our consideration. So what we will do, we will just divide the product with that element. It will end up being 10. So if you see, like, the product of these two terms are 10. So this is what we are doing. Now again back to the code. Here if you see what we are doing, with each iteration we are updating our product variable with the value, and if like by multiplying any of the product we end up being greater than or equal to k, then what we will do, we will shift our left pointer one step at a time until the product is less than k. Okay, and to do that, what we are doing, we are updating the product also by dividing the element at the left pointer. Okay, and at the end, like when we reach the point where our product is less than k, then we can figure out the number of subarrays possible within that range, and we will update our total count, which is the result, and at the end we are returning the result. So let's check out the test cases. So as you can see, the test cases got clear. Let's submit it for further evaluation. And the solution got accepted, and I would say like it has performed fairly well. So yeah, thanks guys for watching out the video. Stay tuned with the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.